Hello everybody. Thank you so much for tuning into my video today. In this video, we're going to take a look at an introduction to the fundamental theorem of calculus, which sounds pretty important because it is, and accumulation functions. And then we're also going to interpret the behavior of accumulation functions that involve area. So we haven't yet learned how to actually take antiderivatives by hand. So the fundamental theorem of calculus, which usually involves taking antiderivatives by hand, we're not going to be able to do that fully today, but we're going to do a little introduction, and we're still going to use what we learned in previous videos to find area under a curve by using geometry or by using a calculator. So first of all, let's take a look at the fundamental theorem of calculus. There's two parts to the fundamental theorem of calculus. In the first part here, it says if g equals the integral from a to x of f of t dt, if you want to take the derivative of g, basically what you're going to do is you're going to take this x, substitute in for t, and that would be your derivative. Now by using chain rule, you'd also have to multiply by the derivative of x, but in this case the derivative would just be 1, so you don't have to write that down. So g prime of x would equal f of x. Secondly, the integral from a to b of a function f would equal the antiderivative of f at b minus the antiderivative of f at a, where f is the antiderivative of little f. Therefore, f prime would be, capital F prime would be little f. Okay, so that is the fundamental theorem of calculus. We're not going to be able to get too far into it today because we don't actually know how to take antiderivatives yet. We will learn that very shortly in an upcoming video. But today we're still going to keep using either area under a curve by geometry or using a calculator. Okay. Then we have something called the net change theorem, which I like to call an accumulator function or an accumulation function, which basically is just rearranging this. Okay. If we were just to add f of a to the other side, you would get this accumulation function here. All right. So accumulation function basically says if you're trying to find the amount of something at b, what you'll do is you'll take the amount at a and then add your definite integral in after that. So the end amount equals the start amount plus the net change. Let's see how this works. Let f be a function whose graph consists of two straight lines and then two quarter circles as shown in the figure below. So straight line, quarter circle, okay? And then let g equal the antiderivative of f, or the integral of f from 0 to x. Find the following values. All right, let's start off with g of 0. So using my expression right here, g of 0 equals the integral from 0 to 0 of f of t dt, okay? So the integral from 0 to 0, and this is true for any number, the integral from any number to itself, there's not going to be any change in that. There's not going to be any area because it's just going to be a vertical line there. There's no width of the vertical line. So if you're going from 0 to 0 or from 7 to 7 or from -3 to -3, it doesn't matter. Your integral is going to equal 0 because there is no width to that integral. G of 1, so g of 1 is going to be the integral from 0 to 1 of f of t dt. All right, so there is a width there. It's 1. So let's take a look. The area under this curve from 0 to 1, right, it's going to be this area here, which is a triangle. We learned how to do this before. We can find the area of that triangle, which would be 1/2 base height. So g of 1 is 1. G of 2. So g of 2 is the integral from 0 to 2 of f of t dt. All right, so there's two ways to do this. We can do this triangle plus this rectangle, which is probably the better way to do it since we already know the triangle. Or you can also do one shape, a trapezoid. Either way, we'll get the correct area. Let's do the first method because we already know we can do 1 plus integral from 1 to 2 of f of t dt, because we already know that 1 is 1, g of 1 is 1. So now we have 1 plus the rectangle from 1 to 2, who has a length of 1 and a height of 2. So that would be 1 plus 2, or 3. So g of 2 would be 3. All right, so now we have g of 4. So what we could do here is we can do g of 4 equals the integral from 0 to 4 of f of t dt. Or, since we already know g of 2 is 3, we can do 3 plus the integral from 2 to 4 of f of t dt, using the net change theorem. So either one of these will work just fine. Okay. This one is going to be a lot easier, because if we did from 0 to 4, we're going to do a couple different shapes. But if we're going to do from 2 to 4, there's only one shape that we need there. So from 2 to 4 is just this quarter circle here. So our answer is going to be 3 plus the area of this quarter circle, who has a radius of 2. So pi r squared over 4, because it's a quarter circle. So pi times 4 over 4, which is just pi. So our answer is 3 plus pi. So g of 4 equals 3 plus pi, or approximately 6.14. Finally, g of 6. So again, there's going to be a couple different ways we can write this. We can write g of 6 equals the integral from 0 to 6 of f of t dt. Or, since we already know what g of 4 is, we can do 3 plus pi plus the integral from 4 to 6 of f of t dt, which is going to be much easier to do. All we got to do now is find the area of this. So 3 plus pi plus the area from 4 to 6. It's a quarter circle with radius 2 again, but it's below the x-axis. So it's going to be negative pi 2 squared over 4. So negative 4 pi over 4, so negative pi. So it's 3 plus pi minus pi, or 3. So g of 6 is 3. Okay, question 6. G prime of 1. All right, so if we want to find the derivative of this using the fundamental theorem of calculus, that would just be g prime of x equals f of x. So g prime of 1 is f of 1. And what is f of 1? It's just 2. So g prime of 1 is 2. Okay, and then g prime of 4 would be f of 4. F of 4 is 0. And g prime of 6 would be f of 6, or negative 2. Then we're asked to sketch a possible graph of g in the coordinate plane provided to the right. We could use values of g double prime as well to help us if needed, but let's see what we got here. So first we got g of 0 is 0, so 0, 0. G of 1 is 1. G of 2 is 3. G of 6 is also 3. G of 4 is 3 plus pi, so about 6.14. So G of 4, right about there. All right, and then we know the slope at 1 should be 2. The slope at 4 should be 0, so we should have a horizontal tangent line there. And the slope at 6 should be negative 2. All right, if we wanted to find a couple values of the second derivative, so g double prime, we can also say that g double prime, well, let's say this first. If g prime is f, that means g double prime would be f prime. So if we want to know the values of g double prime, which would help us with concavity, all we have to do is find the slope of f. All right, but I think we have enough information here to graph this. Basically, we would have something that looks a little bit like this. As our graph. Is that a perfect graph of g? Probably not, but it's probably pretty close to what g would look like. Example 2, using a graph of f prime to find values of f. So pretty much the same problem here. Would f be a function defined on a closed interval? F of 0 is -3. That's going to be very important here. The graph of f prime, the derivative of f, consists of one semicircle and one line segment as shown in the figure to the left. So a semicircle and a line segment. We want to find f of -4 and f of 3. All right, so the first thing we're going to do for f of -4 is we're going to write an integral statement for this. So f of -4 would equal the integral from -4 to 0 of f of x dx. All right, so why am I going from -4 to 0? Because we know what f of 0 is, right? So based off what we said way back over here, this one here, there it is. We know that this would be f of 0 minus f of -4. There we are. So this is going to be f of 0 minus f of -4. Right? And we know what f of 0 is. So that would be -3. We don't know what f of -4 is, but we can figure it out. So f of -4 you know it's going to be that semicircle there, which is going to be, if we got to draw a little rectangle in here. So we're looking for this area here, which we could do the rectangle minus the semicircle. All right, so that rectangle would be 4 times 2 minus the semicircle would be pi r squared over 2. So that would be 8 minus 2 pi. I think that sounds right. So it would be -3 minus 8 minus 2 pi. So it's -3 plus 8, which is 5 plus 2 pi. Nope, that's bad math. I'm sorry. -3 minus 8, which is -11 plus 2 pi. That's better math. So our answer would be 2 pi minus 11. Okay? So the other way to think of this problem, and this might be a better way to look at it, would be to use that accumulation function that we talked about it here. If we want to find f of -4, we can do f of 0 plus the integral from 0 to -4 of f dx. All right? And something we haven't really talked about yet, but basically what we can do when you want to flip the bounds, basically it just flips the sign of it like this. So we can use this accumulator function as well, which is basically the same thing that we just did. And it'll get us the same answer in the end, but it's just a different way to think of it, that's all. All right, let's take a look at part B now. So we are looking for f of 3, right? So let's set up an equation here. The integral from 0 to 3 of f of x dx, we learned earlier, would be f of 3 minus f of 0, right? And we're trying to find f of 3. So f of 3 then would be f of 0 plus the integral from 0 to 3 f of x dx equals f of 3, right? F of 0 we already know was negative 3 plus the integral from 0 to 3 is that area right there. So the first triangle above the axis would be 1/2, 2 times 2, and then minus the triangle below the axis, 1/2, 1 times 1. This would be 2 minus 1/2, or 3/2. So negative 3 plus 3/2, which would be negative 3/2. So f of 3 would be negative 3/2. Okay, our next example says using a graph of f prime to find absolute extrema. This is where things can get a little crazy. Let f be a function defined with the closed interval that we see here, and we know f of 0 is 3. The graph of f prime consists of 4 line segments. Let's see those. 4, 1, 2, 3, 4, and 1 semicircle in the figure below here. Find the absolute maximum of f on the closed interval, negative 6 to 6. All right, so remember, for using the extreme value theorem, right, we need to check all endpoints and any critical numbers that might be maximums. All right, so first of all, let's list all of our possible answers, okay? Our possible answers could be x equals negative 6. There's an extrema here at negative 4, right? There's an extrema here at negative 2. There's an extrema here at 2, here at 5, and then the other endpoint 6. So negative 6, negative 4, negative 2, 2, 5, and 6 are our possible extrema, possible maxes or mins. Okay, now remember, anytime a derivative changes signs, that's where possible extremas are. That's why negative 4, 2, 2, and 5 are possible extrema, because the derivative's changing signs at those points. But we're looking for a maximum. So a maximum would have to occur when the derivative changes from positive to negative. So 2 of these we can get rid of. Negative 4, the derivative is changing from negative to positive, so that's not an answer. And 2, the derivative is changing from negative to positive, so that's not our answer either. Those are possible minimums. Okay, so we have 4 possible answers for our absolute maximum. We know negative 2 and 5 are definitely relative maximums, but we don't know if they're the absolute or not. So we got 4 options here. And remember, what we got to do is we got to check all these one at a time. So x, f of x. We have negative 6, negative 2, 5, and 6. I'm going to make these a little bit bigger here because we got some work to do to find each of these. Okay, so let's start with negative 6, right? So negative 6, if we set up the integral, since we know 0, we know f of 0, right? If we set up the integral negative 6 to 0 of f of x dx, f prime of x dx, sorry, equals f of 0 minus f of 6. I feel like I need to write a little bit smaller here so I can fit this inside this box. Let's try this again. Equals f of 0 minus f of 6. There we go. All right, since we're looking for f of 6, okay, if I was to, sorry, f of negative 6, there we go. If I was to add f of negative 6 over, I would get f of 0 minus the integral from negative 6 to 0 of f prime of x dx. I'm just rearranging the equation to say f of negative 6 equals. All right, we know f of 0 that was given to us is 3 minus, and then the integral from negative 6 to 0. So this area, and this area, right? Let's just kind of go through this and find all the areas one at a time. So the area of this triangle here would be 1/2, 2 times 2, which is 2, but it's negative, so it's under the axis, so it's negative 2. the area of this next triangle, 1/2 2 times 1, which is 1. We could do a semicircle or we could do 2 quarter circles. The semicircle would be pi 2 squared over 2, so it'd be 2 pi. But since it's under, it's negative 2 pi, so this would be negative 1 pi, this would be negative 1 pi. Area of this triangle, 1/2 3 times 2, so 3. And area of this triangle, 1/2 1 times 1, so 1/2, but it's under the axis, so negative 1/2. So the integral from negative 6 to 0 that we need here would be negative 2 plus 1 minus pi, or negative 1 minus pi, which would be 3 plus 1, or 4 plus pi. All right, so our first answer, f of negative 6, is 4 plus pi. All right, negative 2. So we know this is going to be the integral from negative 2 to 0 of f prime of x dx equals f of 0 minus f of negative 2. So f of negative 2 equals f of 0 minus the integral from negative 2 to 0 of f prime of x dx. F of 0 we know is 3. The integral from negative 2 to 0 is negative pi. So 3 minus negative pi, or 3 plus pi. All right, so we know negative 2 is not our answer because negative 6 is already bigger than negative 2. So it's definitely not at negative 2 is our maximum. Let's take a look at 5. So for 5, we're going to do the integral from 0 to 5 of f prime of x dx equals f of 5 minus f of 0. We're looking for f of 5, right? So f of 5 equals the integral from 0 to 5 of f prime plus f of 0. The integral from 0 to 5 would be negative pi plus 3, or 3 minus pi, plus f of 0 we know as 3. So this would be 6 minus pi. So f of 5 is 6 minus pi, which is definitely not bigger than 4 plus pi. 4 plus pi is 7 point something. 6 minus pi is 2 point something. So again, that's not our answer. So far, negative 6 is still our biggest value. Finally, we got to find f of 6. So integral from 0 to 6 equals f of 6 minus f of 0. So f of 6 would equal the integral plus f of 0. The integral from 0 to 6 is negative pi plus 3 minus 1, or negative pi plus 2, or 2 minus pi, plus f of 0, which is 3. So this is 5 minus pi. So f of 6 is 5 minus pi, which is definitely not bigger than 4 plus pi. So the absolute maximum of this function on this interval is 4 plus pi, and it occurs at x equals negative 6. And that's the answer we're going to write out here. Okay, the absolute, or we could just even say f of x has an absolute maximum on negative 6 to 6 of 4 plus pi at x equals negative 6. All right, so just recapping that problem. First, we found all of our candidates, which there was 6 of them. We eliminated negative 4 and positive 2 right away because those are relative minimums. We checked our other 2 possible extrema and our endpoints. We found the biggest number was 4 plus pi, and that occurs at negative 6. Okay, the next thing we're talking about is rate in, rate out problems. The examples that follow in the next couple of pages very closely resemble a type of problem often found on the AP Calc exam in the free response section. They are commonly referred to as rate in, rate out problems. You might notice that these full FRQs, free response questions, ask you to find information that pertained to concepts that were previously taught in Unit 6 or in prior units as well. Having confidence in solving problems like these can have a significant impact on your AP score. All right, we will definitely come back to these later on in topic 8.2 and when we do our AP Calculus review for the AP exam. But now let's do a little intro to them. All right, this is a calculator problem called posting memes. After the AP Calc exam, students post memes at a rate of m of t for 24 hours, where m is measured in students per hour and t is in hours after the AP exam ends. After 12 hours, the College Board begins canceling scores of students posting memes at a rate of c of t from 12 to 24, where c is measured in students per hour and t is in hours. Let s of t be the number of students who have posted memes but have not yet had their scores canceled. Okay. Question A says, after 24 hours, how many students have posted memes? Round your answer to nearest whole number. So the question you want to ask yourself here, am I talking about M, C, or S? This is just talking about posting, not about canceling, not about students who haven't had their things canceled, just how many have posted. So that's just M of T. All right, so this question, all this is really asking is, what is M of 24? Okay, well, not really M of 24, but the amount of 24 after 24 hours that M would give us. All right, so it's going to be the integral from 0 to 24 of M of t dt. All right, because this is the rate that people are posting. So if we add up all those rates together, we'll get our total amount. At this point, we have no way how to integrate that by hand. We will learn how to do that. But for right now, since this is a calculator problem, we can just do what we did on earlier videos using our calculator. So on your calculator, on your home screen, if you remember how to do this, just go to Math and then look at number 9, the FNINT. And basically type this in, except instead of typing M of t, type in what M of t is. So 231 sine pi t over 24. Remember that your calculator needs to be in radian mode unless otherwise specified. Okay, and if you're doing this correctly, you should get 3,529 approximately students. And it says around the nearest whole number because you can't have part of a student. Either it's a full student or it's not a full student. Okay, so 3,529 students post memes. Part B says, at t equals 19, is s of t getting larger or smaller? So this one is actually asking us for s of t, okay? So remember, s of t is basically the amount of students who posted minus the amount of students who have had their numbers canceled. Okay, so if we want to write that down in an integral form, if we want to find s of t, that would be the integral from 0 to t, whatever time t would be, of m of t. That's the amount of people that have posted. But we're going to subtract out the integral from 12 to t of c of t dt. And I just realized here I made a little bit of mistake, but that's good. This is a very, very common mistake. We can't use the same variable in our bounds that we used in our equations, okay? And because this is s of t, we want our bounds to say t. So all we got to do is change these variables to anything you want, preferably not s, m, or c, because we're already using those letters. X is always a good choice for that one, okay? So we want to know, is s of t getting bigger or smaller? In other words, we want to know, is s prime of t positive or negative, right? So s prime of t would equal m of t minus c of t. This is only for 12 to 24 hours, which is fine because that's where 19 is located, 12 to 24, because again, c doesn't really exist until 12, okay? So we were trying to find s prime of 19, and that would be m of 19 minus c of 19. So in your calculator, basically just type this equation in with 19 in for t, minus this equation with 19 in for t, and see what that would be. We don't actually care what the value is. All we care about is if it's positive or negative. I mean, we have a calculator, so we can find the value pretty easily. And the answer would be negative 19.425. But all we really care about is the fact that it's negative. Since s prime is negative, that means, so s prime of t is negative, s prime of 19, is negative. Therefore, S of t is decreasing at t equals 19 hours. We don't really care what the value is, as long as we know that it's negative. That's all that matters. All right, then part C. At what time is the number of students who have posted memes but have not yet had their scores canceled the maximum? How many students have posted memes but have not yet had their scores canceled at that time, and justify your answer? All right, so to do this, we want to know basically what is the maximum. That can occur at an endpoint, or that can occur at a critical number. All right, so our endpoints here are 0 or 24, so we definitely have to check 0 or 24. And then we also want to know when S prime of t would be 0. So we have our calculator here, which is great. Basically what you want to do is you want to let y1, well, there's a lot of ways to do this. This is what I would do. In y1, I would type in m of t minus c of t. Okay, so basically just type out in y1 this minus this. And since we already know what s prime of t is, we want to know when that would be 0. So when would this be true? Okay, so since this is in y1, find where that hit 0 between 0 and 24. Okay, you can use a graph to do that. So if this is y1, go to the graphing page, see when that would hit 0. It would happen a couple times, twice actually. At t is approximately 0.099 and 18.778. So we have 4 candidates to test. Our 2 endpoints, which are 0 and 24. And our 2 critical numbers. Okay, so for each one, we're just going to say, all right, so S of 0, well, at 0, nobody has posted anything yet. So that's 0. That's easy enough as it is. For S of 0.099, C doesn't exist yet. So all we're doing for this one is the integral from 0 to 0.99 of m of x dx. All right, you can do that on your home screen. Just type in integral from 0 to 0.099 of m of x dx, and you should get 0.148. Probably not going to be our maximum. All right. Now for S of 18.778, you got to do the integral from, let's change up the color here, the integral from 0 to 18.778 of m of x dx minus the integral from 12 to 18.778 of c of x dx. Sorry about the bad handwriting here, but I'm trying to fit this in there. And again, you can do that on your home screen. You should get 2,774.474. That could be a maximum. It's a pretty big number. All right, and then finally for 24, same thing. We're going to do integral from 0 to 24 of m of x dx minus integral of 12 to 24 of c of x dx. Do that on your home screen. You should get about 0.163, which is definitely not our maximum. So our maximum is right here. All right, so write out a sentence here. I'm a little out of room, but write out your sentence. The maximum number of students that have posted memes but have not yet had their scores canceled is approximately 2,774 students, which occurs at time t equals 18.778 hours. Which brings us to our last problem, another calculator problem, example 5. The rate at which people enter the Indianapolis Zoo on a given day is modeled by the function e, defined by e of t. The rate at which people leave the zoo on the same day is modeled by the function L, modeled by L of t. Both e of t and L of t are measured in people per hour, and time t is measured in hours after 8 a.m. These functions are both valid from 0 to 12, the hours which the zoo is open. At time t equals 0, there are no people in the zoo, obviously, because it's closed. At least no customers in the zoo. A, how many people have entered the zoo by 12? So entered only. That's all they're worried about. Okay? So we have our calculator available to us for this one. We are looking for the integral from 0 to 4 of e of t dt. You can use your home screen for that, no problem. You should get 203.068 people. Okay, but again, can't really have half a person there, so 203 people have entered the zoo. 20% of those people who leave the zoo are selected at random to receive a special discount ticket for a return trip to the zoo. How many people have received a discount ticket by 5 p.m. t equals 9? All right, so first of all, let's figure out how many people left the zoo. So left the zoo would be L of t. So the integral from 0 to 9 of L of t, again, use your calculator to do this, will be 79, sorry, I'm giving away the answer here. Let me do this in my calculator really quick. All right, it would be about 396 people. Again, we're talking about actual whole number of people here, so about 396 people have left the zoo. But it says 20% of those are selected at random to receive a special discount ticket. So we want 20% of that, or 1/5 of that. So 396 divided by 5 would be 79 people. Actually, I can't read my own writing. This would be 395 people. 395 people. So it'd be 79 people are receiving a special discount ticket. Question C, let n of t equal the integral from 0 to t of e minus L. Find the value of n of 10, explain the meaning of n of 10 in the context of the problem, then find n prime and explain the meaning of n prime as well. All right, so n of 10 would be the integral from 0 to 10 of e of x minus L of x dx. That's something we can easily do on your home screen as well. It's going to be about 273.635, okay? Which, again, we can't really have people, so let's say 273 people, because we can't have part of a person. What does that mean? That means that there are 273 total number of visitors in the zoo at time t equals 10, okay? So if we want to write that out, n of 10 represents the total number of visitors who are still in the zoo at time t equals 10. Because remember, E is how many people arrived, and L is how many people have left. So subtract how many people have arrived minus how many people have left, you get how many people are still in the zoo. All right, so n prime, first let's do n prime of t. All right, so the n prime of t would just be e of t minus L of t. So n prime of 10 would be e of 10 minus L of 10. So all you're doing here is putting 10 into e and 10 into L and subtracting those numbers. And you should get about 6.228 people per hour. So what does n prime of 10 represent? It represents that the number of visitors in the zoo is decreasing by approximately 6.228 people per hour at time t equals 10 hours, or at 6 o'clock p.m. Finally, question D says, at what time t for 0 to 12. Does the model predict the number of people in the zoo is at a maximum? So this is, again, talking about the same problem that we did here on C. All right, we're trying to find a maximum. So we know we have to test 0 and 12, but we got to see if there's any critical numbers as well. So let's set up our equation here. N of t equals the integral from 0 to t of e of x minus L of x dx. So we want to know, when does n prime of t equal 0? Well, n prime of t is just e of t minus L of t. We want to know when that would equal a 0. So again, a couple different ways to do this. What I would suggest is in y1, typing in e of t minus L of t, and just looking on the graph and seeing when that would equal 0. If you want to pause the video to do that, go ahead and do that. We're going to get two candidates here, 0.008 and 8.134. We also have the two endpoints, 0 and 12. So we have 4 possible answers for this problem. All right, so t, n of t, 0.008, 8.134, and 12. Okay, so again, we're going to use our home screen here. For 0, well, at 0, there's no one in the zoo, so we know that's 0. For 0.008, remember, all you're doing the integral from 0 to 0.008 of e of x minus L of x. So you can type that out in your home screen, and you should get a negative answer, which is probably not going to be our maximum, you would think. You're going to do that same thing for 8.134 and for 12, and your answers that we should get are these two. So which of these 4 numbers is your maximum? Clearly, this one is. Okay, so if we were to write out a sentence for this, the maximum number of people who are in the zoo is approximately 281 people, which occurs at time t equals 8.134 hours. Okay, so the maximum number of people in the zoo is 281 people, which occurs at t is 8.134 hours. Okay, so that was a lot in this video today. There's a lot of really important information talking about the fundamental theorem of calculus, which is called the fundamental theorem of calculus because it's so important. That's it for this lesson today. Feel free to go back and rewatch any parts of it that you might have had a little trouble with. Otherwise, thanks again for looking into this video today, and have a great day.